Hi, everyone, and welcome back to the Information Bottleneck, the podcast that squeeze out the relevant information for AI. I'm Ravid,
And I'm Alan.
and today we are going to talk about several topics. And let's start with some news and recent information about AI. And I think the first model, or the first news that we need to start is the Nano Banana. The first, like maybe the recent Google image editing tool or image editing model. What do you think about it? Did you try it?
I unfortunately have not used it just yet, but I have seen a lot of the outputs and have heard a lot of reviews from people who have used it, and I've heard that it's really quite good at following, in particular, like several steps or quite a bit more like complicated instructions than in the past. One thing I do know is that it still has a little bit of the problem which plagues these all, which is that even if you ask for take an image and like remove something from the image, the reconstruction of every part that wasn't removed is not absolutely perfect. And that perfection of reconstruction is extremely important.
Yeah, I agree. This is also so. I try to play a bit with that, and it's impressive. Like it looks much more, that you have 3D inference in 2D images, right? That it knows to understand like the structure and the different objects. I also really like the consistency, and the memory that if now you ask it to generate several images in a row, like it really knows how to track and to be consistent over time. It's very impressive and very cool.
Absolutely.
Yeah. Okay. What about the new DeepSeek? DeepSeek v3.1. 671 billion parameters, a mixture of experts, trained on roughly 15 billion tokens.
Brilliant.
What? Trillion, yeah, trillion, right. No one train on billions anymore. 128k contacts. It's a great improvement from the last one, and maybe the most the best feature is the hybrid reasoning, right? That you can switch between thinking and fast mode. Yeah, it looks again here. Most of the reviews or most of the people that use it said that it is quite important. It is quite impressive. It looked that it's kind of like the same performance as other models or like previous models, but much shorter, right? Much fewer tokens. It looked that they spend a lot of time in order to make it efficient in tokens.
These are very interesting or developments. I guess I have so many questions, and I also want to preface that I have not used this model yet. I also see that DeepSeek is using a little bit of Huawei's processors, as you've noted in these notes here, to train smaller AI models. But I want to point out that they also talked about how Huawei's chips are primarily used for inference in their attempt to scale them up for training of the big model, like the big release, instead of those like secondary model releases, was, that got in the way of the model coming out, and that's why it took so long for DeepSeek to release another checkpoint. But I actually have a question for you that this starts that this discussion I want to start off with, which is and I should also preface this by saying that like I got into a minor disagreement online with somebody about this question where I was of the impression that the jury was still out about if mixture of experts versus dense models, like which was better or which would be used even among the big three, right? And but now I'm seeing people tell me, hey, they have to be doing mixture of experts. Dense models are gone. It's not possible. So I'm very curious what you think, and for any information you have on like what the majority of the models are going towards, especially going into 2026.
Yeah, it's a good question. I think like these days, most of the models are a mixture of experts, right? And it looks that it's kind of mixture of experts. Some of it like combined dance and mixture of experts or something like that. Um, and of course, like there are a lot of, let's say, pros and cons, right? All of us knows these pro pros of dance models, right? That like it's much easier to train them and they're much more stabilized versus mixture of expert. That now when you train mixture of experts, it's a bit more difficult to train, but from other hand you can you can scale the number of parameters like by a lot, right? And you have more capacity and all these hand waving thing. um I must admit that like I'm mostly interested in what does it mean even mixture of experts, like what kind of information each expert can catch, right? Because it looks a bit weird. Think about it. Like you have different experts, but it's not that like you have a very clear understanding. We don't have a very clear understanding what these experts actually mean, or like what these experts actually learn, right? um it's not like I don't know, an ensemble of models that you train different initializations and then you can say, okay, so you have some stochasticity Bayesian style models that actually helps you to get better performance, right? And it's not that you train the different experts on different subsets of the data as classical models are doing. um Here we have something that like, again, you can handwave that for each example you need a different subset of the network that we will activate, right? That like you need different properties for each sample, or like for each prompt if you want. But I don't think we have a good explanation or a good understanding what does it mean and why we need experts.
Yeah, I'll point out that my understanding of, and maybe they've updated, but my understanding of the technique that's used circa the initial DeepSeek release is auxiliary load-free balancing, right? Which is specifically the idea that the experts are trained in such a way to guarantee that they are called, an equal, not just an equal, but called an optimal number of times, so that way you're using as many of them as possible at inference time and not focusing on one small part of them. Like you're not focusing on two experts like 80% of the time, using them all an equal amount of time. And so that seems in my mind analogous to like if you wanted to try to apply it to the brain, right? This idea that the brain has, I believe, things like lateralization, and when thoughts or actions happen, I mean, we're not using uh the whole brain, but obviously like significant portions of the brain are all mediating different properties all at once, and are not, I think, efficiently utilized in this like guaranteed 20% kind of optimality. And so I find it that it's not, obviously, like there's not a easy way to interpret, and maybe there's no particular interpretability per se, or maybe there is incidental, like higher structure and that comes out of this approach, but in my mind, I just find this as a purely like a computational optimality trick. And but I don't know. I mean, I think you're the one that knows a lot more about these kind of connections than me. I'm definitely speculating a lot more.
Yeah. Maybe at some point we'll talk about neuroscience and AI, but at least at that point I will put my neuroscientist. I did a computational neuroscience PhD in computational neuroscience, and every time that someone is saying about the connection between AI and the brain and current models and how the brain works, I'm putting this head and say that all these explanations are really nice and sound very good in retrospective, but and it may be, but we actually don't know. I think the problem, we don't know how the brain works, and we don't know how artificial models work. So we don't know the connection between the two.
Well, let me put it back into the phrasing I think we can more agree upon, right? And mind you, the comparison that I'm about to draw on was between Mistral Large and then I believe Mixtral, and I think Mixtral might have just been a pretty bad model here. And I can go back and I probably will go study like log prob distribution charts of the to understand. But what I remember is that Mistral had reasonable log probs, where Mixtral had extremely, I would call it fried, like extremely high values, extremely low values. And it actually made existing sampler settings, right? You had like really not work. And so you'd have to tune these a bit more differently. And so I'm curious there, because I have this theory, right, that the quality of the log probs is correlates or is possibly the exact way to measure the quality of a model, in a sense, with the idea being that the more that your model can resist temperature, like harming it, the better your model is. And so this is why I talk about how, like with Gemini, I can get it up to like temperature of 2 with increasingly lenient sampling, or even turning it off, right? Like, and so that's, if I can do more noise and distortion and still preserve capability, I wonder if this is like a way to quantify intelligence in a way that's like information theoretic, right?
Yeah, yeah, it's a good point. I think there are a lot of, let's say, good arguments about the relationship between compression, representation, quality, and intelligence or learning, if you want. And of course, at the end, it boils down to the trade-off between compression and 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 prediction. Okay, so and the whole point of compression, if you want, or representation learning, is to get good representation that we will compress the data from one hand, but at the same time we'll know, or like we'll understand how to separate between noise and what you really care about. And I think like in your case, and at least when you increase the temperature, it's a good sanity check, if you want, that we actually know what does it mean, the noise, and we can ignore it even if we increase the temperature.
Yeah,
So yeah, it can be interesting.
well,
Yeah.
I had another, I guess, more questions, right, related to this for you. Right. So then we have trained on 15 trillion tokens. I seem to recall something around 8 or 10 trillion on the initial release. And so now the question in my mind is what, and also I didn't look at where their context window cutoff is on pre-training or post-training. That matters too, like the date, and even the distribution. Like if it's only like 0.1% of it from, the last 6 months, that's not meaningful, even if they can rubber stamp it somewhere, right? But I'm just curious as to your thoughts on the tokens and
and the
What?
data. Yeah, and maybe like the most interesting part is the synthetic data, right? Like now these days everyone are trying synthetic data and are trying to use synthetic data. Um, and I think from a research perspective, this is very, very interesting, right? There is all these theoretical works about synthetic data, and that synthetic data, like basically with just synthetic data, your model, your will collapse. If you train again and again on synthetic data, there are some theoretical work that show that you will collapse at some point. But of course, in practice, it doesn't happen, right? And how to measure and how to quantify the quality of synthetic data and the diversity of synthetic data, and what does it mean even, synthetic data, right? There is a really nice work in Vision that, like, for I think maybe 5-6 years ago, Yair Weiss from the Hebrew University trained on GANs. Okay, so for the younger researchers, GANs were quite I don't know, popular generative models a few years ago, and people were really excited about it. And he showed that actually, so he looked on very let's say very clean case of Gaussians and mixture of Gaussians that he give the model to learn these data sets, and he showed that like these models actually generate very specific subset of the training, if you want. Like they don't actually generate the whole subset, the whole distribution, if you want, but very particular points or areas in this distribution. And I'm wondering if this is actually the case also here, right? So it can be very interesting to check it. Like, what are the properties of these synthetic data sets, and what are the distributions, and how they look like, and how they different from real text. So yeah, probably people are doing it right now as we talk. But it can be very, very interesting. My intuition is that they contain a much cleaner, less noisier amount of information that you can actually you can use, and you can extract this information much easier. But how to quantify it, and how to say this piece of information or this piece of text contains a lot of information versus other piece of text, this is, I think, an open question.
I think perplexity, right, is really excellent.
Maybe. I think we should talk about it later, maybe in another episode. I think there are pros and cons to look on perplexity, but we don't have time right now.
Yeah, and here I'm referring to not the company, but like the measure of surprise per model here, right?
Yes. I think the measure of surprise it has a lot of let's say advantages when you look on it. Also, so my background is information theory, and perplexity has really close connection to information gain, or like surprise, if you want, or like how much you learn from this text, or how much this text gives you to the total amount of information that you have. Okay, how much bits of text on average you can gain. So it's very important, but I think at the end, like, it depends on what you want to learn, and again, how you separate the noise, or like the things that you want to learn, and are important from the noise and the things that are irrelevant to your model.
Yeah, yeah, and I think the this whole discussion about synthetic data also gets to this question around interpolation versus extrapolation, and even um, do the majority of problems, or like, can we even figure out for problems when interpolation, which is the idea of sampling from all the possible things that the model has, I would call it, defined under its latent space, right? Versus putting something in what we would call an undefined or untrained region, or even, um, detecting what that is, quantifying what that is. I guess the idea is like something that's truly novel versus something that's almost entirely or even completely a regurgitation or mixture of all the previous ideas. And I always say the same thing on this, which is that it's really hard for us humans to know when extrapolation happens. We tend to only see it in some cases hundreds of years later, right? William Shakespeare, I think, was a bit famous in his own time, right, but wasn't considered greatest English poet until well after his death, for example. So um
Yeah,
yeah.
and also there is now these days there is the question: does it matter? Right? It's not that we have, I don't know, 1 million data set that you train on, and then you want to check how much you can generalize to other piece of samples, right? If you train on the whole internet and you have so much information and so much data, does it matter if you generalize or you just memorize? I don't know. It's a good
Well,
question.
I'll point out one other concern, and I'm seeing this more and more. I mean, there's been now many papers that show LLMs influencing humans, interpersonal, even spoken communication, like massive increases of people using words like delve, certainly, and a whole lot of even others that are only a little bit more subtly upweighted, that are maybe like not top of mind, but very clearly you're like, oh yeah, it talks like that, right? And things like this are monkey see monkey do. Suddenly humans start talking this way, and I don't know, I played a whole video game called Metal Gear Solid 5 from Hideo Kojima, of all people. Really weird Japanese game, but really I encourage you to, at the very least, like, if you don't play it, there's this like cutscene of like Skullface and who's like the main bad in the game, and Snake talking all this, and Skullface is like, yeah, I'm gonna infect humanity with this like linguistic parasite to conquer them through deciding how they're gonna say things. And like, we accidentally did that in AI. This is horrible, I really think, because like, I really believe that the linguistic diversity of humanity has been maybe polluted forever, if we can't, like, at the minimum, anti-slop models, right? Like, this is where, like, the ability to defeat slop, as which is like over-representation of these phrases, compared to, I would call it, pre-LLM, like, dictionary baselines, and from there kind of be able to get a communication that doesn't scream that it was like generated by AI. Because I'm seeing this and it is just so frustrating, because it's also now getting harder to be like, oh, did somebody just be influenced by all the AI they saw, or did they just use AI to write something? And I normally don't have a problem with somebody using AI to assist them. It's just usually a sign of like laziness, which is to say, why, Johnny can't prompt. There's a paper titled "Why Johnny Can't Prompt," in reference to the fact that most humans don't even put much effort at all into prompting, and that whole thing, it, I'm normally not one to like defend the whole argument of like, weak time, or good times create weak men, like, if we that kind of like circular thinking. But like, I do think that this kind of intellectual laziness at scale needs, like, it starts here and can possibly be mitigated by anti-slopping the models.
Yeah, I agree. Like, it's also related to all this discussion about if AI will replace developers and things like that, right? And we see that these days it's much harder for juniors to actually to get into the industry or to get their first job, right? Um, and I think it's related because like at the end, AI and all of us knows it, right? Like for coding, it's great. It's maybe like the optimal framework for AI, right? Like you have a lot of verifiers, like natural verifiers, and it's very like closed framework that there is some very strong structure there, and and at the end we see that if developers is using AI all the time, and like if junior developers start to use AI all the time, like his coding skills are becoming worse, right? Like, or like even like the code that he generate is much worse than a code that a non AI user is making. But for senior people, it's not like that. And senior people actually know how to use AI in order to make a very well-structured, high-quality code. And I think this is, again, like you need some basic structure, like you need some basic skills and to understand the concepts in order to use these tools, and in order to use models for better for
Yeah, yeah, absolutely. And let me just go back up to some of the next questions. I would say, you mentioned the same scores with 25 to 50% fewer tokens on benchmarks. I think some people might think that there's this implication of, oh, if we just spend more tokens, we get even better benchmark performance. And maybe that's even true on the benchmarks. I do not actually experience this on real world problems. I find that the thinking process can either go into loops in a lot of cases or go really haywire, especially on models where I can actually control it. And maybe that's good in some cases, right? I definitely think that this kind of creativity is somewhat abrupt and maybe not always expected and kind of unique of letting models run on for a long time. But I find that I don't my own intuition around the idea that every individual next token dilutes the context of the previous and gets closer to the effective context window. And so I want to spend the fewest tokens to get me the right answer, which I guess they're saying, oh, well, we do that. But I guess what I'm trying to say is more tokens get better results, but you have to do context management, and that's really hard. Like nobody has that solved yet. Like context compression in long-term, running AI agents is like, name of the game. There's tools that actually are basically just like highlighters effective that don't care about grammar, that take your prompt and delete words that are, deemed to be the least important for the LLM to get the prompt correctly done, and are probably at the heart of this kind of technology, which we had a colleague actually who was on, I believe, Jonathan, I think, had done some of that work, if as you recall, Ravid. But yeah, really fascinating stuff.
Yeah, I agree. I think we had this point I don't know a year ago that everyone were so excited about chain of thought, and now we can just make more test time compute and all these things that you increase the capacity of the model, and now it can generate everything. And if you increase the length or the chain of thought, it will be better. It doesn't matter. And now I think we have in the recent months, we understand that it's not the case, and it's actually much more complicated, right? In some cases you need this, and in some cases it actually hurts you, and in some cases it doesn't matter. Like in some cases you can just cut all these reasoning tokens, and basically you will not see any difference. So I think again, it's complicated, and we don't really understand what are the cases that we need it.
Yeah. I do like that there's a bunch of libraries now that kind of implement inference time reasoning strategies. For example, the deep confidence one that this bombshell paper claiming 99.99% accuracy on, was it AIME, with something like k equals 5, basically 512 attempts at the problem, with a trick of if you're detecting in the log probs that you're probably off base, just quit and try again. They're doing it faster, like an effective, reasonable amount of time. But what I'm more fascinated by is all of what you said is probably true about how many of those tactics are more placebo than are expected. But for example, they have things like they call devil's advocate or debater style, and that, I know, when prompted correctly, will significantly eliminate sycophancy, which means that models are more likely to not just be too agreeable. And I want to point out now that there's been a bunch of people now who are like getting AI psychosis, including some people who are pretty highly intelligent, where the model, and I think in the case of this last one, where it was some tech executive who got convinced, and by the way, I want to point out, I'm a little bit tin hat paranoid of my own, right? Not in this sense, but per se, but he got convinced that his wife was secretly an intelligence asset, and that he had to go shoot her. And he did, right? and this is now, I think, another case of a clear kind of psychosis leading to a death.
Yeah.
Alongside that, like, 14-year-old, with the chatbot scenario on character AI. So the sycophancy literally kills. Like, we have to get this out of the models. Also,
Yeah.
we need to get this out because I'm so tired of these models, like, no, don't be like willing to tell me I'm freaking wrong and stupid and have to reevaluate myself when it makes sense. Like, please tell me I'm wrong.
Yeah.
I'm
Yeah.
begging you, don't agree with me.
Yeah. No, and this is a very difficult problem to solve, right? I I really don't know how we are going to solve it, because like you have a trade-off here, and this trade-off is very again, it's very specific, right? Like it's not clear even what is the right answer. Um, and do we need like to give the user the option to tune it, for example? Like in some cases we want to tune the disability, in some cases we don't want to do it. I don't know.
And related to that, I actually look, the UI UX strategy of get rid of every possible setting, even though there's like hundreds of them that influence the output of these models. It makes sense to make it like simple, like Google search was: one text box, you type, you press enter. That's great. But in doing so, all the like little disclaimers you put at the bottom about, hey, this is going to be wrong sometimes, go fact check everything, and this isn't, that's nothing compared to the frustration that a human has of having to tune some freaking knobs into realizing that something isn't like a human, and all these, and that what they are hearing is a I don't know, like looking at a mirror that may not be telling them anything at all on base. Like it will hopefully dissuade that kind of psychosis. Maybe I'm wrong. Maybe people will get it anyway and like tune it into like the most psychosis-inducing mode possible. That's probably what at least a couple will do, right? But I think that it will also dissuade a lot of people who might be on the fence from concluding now that these systems are accurately, responding to them in a way that a human would.
Yeah, but I think it's also related, like all the big companies want control at the end, right? Like they spend so much time and effort in order to post-training these models and like to wrap them with a lot of guidelines that helps them to prevent from these models to do this or that, right? And if you give the user, then if you give it like the option, they will success to break it, right? Like we know that it's quite simple to break it, right? Like you can pre-train it again, or like continual pre-training, and like to do all these adversarial attacks that break this thin layer of post-training that the companies try to put. And I think it's a huge risk for these companies. We all remember I think it was Google, right? That with their image detector that detect different people as animals and things like that, right? um,
Uh,
yeah,
bad look.
it's a problem, right? It's a
Yeah.
problem, and when you have more control, like the user has more control, they can break it easily.
Yeah, you'll find the racists will create racist AI that will try
Yeah.
to apply every possible. Yeah, no, the implications are bad. But I think we have so much more to get through. I think I'd love to move on to this question you posed, which is like, is it a good time to be an AI researcher? But no one like knows where the field's going. In particular, you alluded to this with there's now quite a bit of also scientific research showing that there are job losses happening due to AI, primarily in coding and also creative and entertainment industries at the junior level. And that it's getting way more extreme to the point now where like the most recent computer science graduate cohort has like pretty bad unemployment numbers at this current moment, in comparison to majors that used to be the ones they were dunking on, right? And mind you, I think that juniors in AI who like specialized in AI or like have submitted something to the ACL, even a work, I think those guys are not struggling to get a job, to be clear. I'm talking about people who are like, I'm not into AI. I'm like a networking person. I don't know what this cursor thing is. Like I think the term legacy is insulting, right? But I think that the AI crowd might perceive that crowd as being legacy, and that is I don't know. This is pretty bad, right? I think that a lot of some of the worst fears, or at least moderate fears that people have about like short-term negative impacts of this technology are coming true. And I don't mean that, to be clear, I do not mean that in the context of arguing for like, oh, work is good or yeah, like as an affirmative thing. I'm like anti-work in the sense that like it's good for us to be able to reduce labor and get more for less put in a lot of things. Like work isn't good just for its own sake in my mind, right? But I mean this more that a lot of people who really need to earn money for themselves are having a lot harder of a time to do that, right? Like that's the reason I think that this is like really disruptive, without like fundamental change in the economic system, which no rich person will tolerate, right? So yeah.
Yeah, I agree. I think also like from the perspective of let's say startups, it's a huge difference, because like so I spent the last 3 weeks in Tel Aviv, and in Tel Aviv it's crazy. Like everyone are trying to make their own startup, or like to raise money, or they just raised money for their startup, and there are a lot of VCs that are walking around and trying to understand which company will be the next unicorn. And it's crazy because all these startups need exactly the same typecast. Let's say the AI researcher that know how to make these models work, and that know how to train or adjust the huge models to a very specific use case. And it's really like this typecast, it's really rare, and it's not clear where to find them. And it's a huge problem because you have a lot of ideas now these days, right? AI become much more easier, in the sense that it's really clear how to or where to apply it, right? In which cases now AI can help me, or LLMs can help me, but from the other hand, like we don't have enough people in order to use these models, in order to train these models, and um, I'm not sure what is the solution here. And I
Well,
think I think no one actually know the answer for this.
yeah, and the funniest part is, well, we talk about how, you know, Saturn devours its own first, right? In AI, getting really good at coding. The very hardest type of code, right? And also the most recent frameworks and code, like for like controlling AI systems, is the stuff that's not well represented in models' training data. There's a lot of good research that shows like CUDA GPU programming that relies on non-parallel kind of like you know, thinking is really hard for LLMs. And yes, you can respond with, you know, give them proper access to debuggers and tools and turn it into verifiable rewards and agentic access. That is true. But also, people who code GPUs know that all those tools are way harder to use, way harder to interoperate with, way more bespoke, and all of this costs a crap ton of money to get good at. So I will say, I especially kind of did a tiny bit of like fake it till you make it to get into an initial role for a time as a consultant, where I could actually have a few hundred GPUs for bursts in order to do, you know, our attempt at pre-training models on, in our case, copyright non-infringing data sets at 273 Ventures. But before I had my boss, you know, at that time kind of take a chance on me, I'd never properly touched more than 8 GPUs at once. And who has, right, outside of some very specialized places? And look, a lot of people are finding that, you know, they can be like, oh, I worked at Google and I literally physically saw 1,000 GPUs and saw a guy next to me who like ran a job once. Like, I ran a job once that had 120 GPUs. So suddenly I must be an expert now on like, you know, 1,000 plus GPU. And it's like, the reality is no, like very few people, very few, probably 1,000 people on this planet at this current moment, I think are qualified in my mind to like look at and set up a GPT-5 like training run. Probably, and we need a way to like create more people, and probably do it in a way that isn't just, oh, go to Joshua's lab or go to whatever person with the most high citations. Because I've heard startups say word for word, go to those guys' labs and poach your students. Are those students just like, I'm pretty sure those guys weren't like, most of their students aren't like, oh, super, you know, high GPU usage. A lot of them have research agendas that probably are very different, right, from this problem. So I think that the talent shortage and issues with AI, it's this complete cluster. It's this complete disaster right now. I don't know what to do about it either. Well,
Yeah. Yeah, I agree. Maybe it's a good point to go to our let's say main part, right? You just said about the GPUs, and that there is no one that actually know how to train them. So maybe let's talk about the only thing that an AI researcher needs these days. Um, and this is not the I don't know, the massage room, the office, or the hockey table, right? All of us need a lot of GPUs, and it's a huge problem, right? Like I don't know, maybe 10 years ago we have one GPU near our table that we can train our models and hope for the best. And if now we are in a very big company, you know, Google, Meta, OpenAI, then we don't need to know a lot of the structure and the clusters of the GPUs. But besides that, all other peoples need to know, need to understand GPUs and GPUs clusters, right?
yeah, and there's so many technologies, some of them legacy, that you might have heard of, like Slur, right? And a lot of technologies that are quite a bit newer, things such as Kubernetes, clusters, and then going to like hardware, like names of SKUs and all these things related to like how to make GPUs talk to each other faster. But I think I wanted to, lean just a little bit more on my experience as an ex cloud engineer, titled various times things like ML engineer and then principal ML architect at Oracle Cloud Infrastructure from 2020 to 2023. They continue to rapidly build out their GPU cloud, and I'll discuss their kind of market position, but I'll just give like a really quick discussion of the big players and sources that people have for GPUs today, right, in our options. And it is a little bit of a race to the bottom in some parts of the market, right, in terms of price for these things, but the price of GPUs is really king for, in most cases, price and availability, and maybe reliability, and in maybe that order, depending on the customer. But I would say, first of all, you've got the big incumbent, AWS. They are very expensive. They're the premium cloud. A lot of their data centers are not designed for the kind of world we're in yet. Certainly the power and cooling infrastructure is often not, but they have the most volume. And uh, as a premium cloud, they're preferred by a lot. But Azure from Microsoft has in recent years taken a lot of market share by being just a little bit cheaper, having in many cases better user interface and user experience, and competing in many other ways that would be too long to kind of go through here. And then you've got GCP, which interestingly enough has GPUs and TPUs, right? They're on tensor processing units. The GPUs are also quite expensive, but the TPUs mean that the most Google engineers have access to far larger amounts of compute than even their competitors at a place like Meta might. And that's kind of convenient for them at Google, though TPUs are hard to efficiently utilize for the rest of the industry. And then we have another source. Sorry, I'll quickly say Oracle's trying to become part of this big three. They're a hyperscaler, but they're competing hard on price. Trying to be a lot cheaper. Then you've got these neo clouds, as we call them, which are smaller companies. Not holding millions of GPUs, but holding in the hundreds of thousands or high tens of thousands, right? And these are, I think there's 4 that are probably the market leaders at this time, which would be Nebius, Lambda Labs, Crusoe, and CoreWeave. And I don't want to go too much into their differences, but they're kind of mostly competing on the value side of the market, and are rapidly gaining market share and revenue and etc. And then you've also got like HPC companies who are midway into pivoting into this, or even cryptocurrency companies who are like having to debate about, oh, do I mine Bitcoin or train AI, right? Because it doesn't even matter if AI is way better than crypto, right? Crypto is just stupidly overvalued, right? So it's like, it makes sense to like have that discussion. And so it's this world of resources that we have to procure and become knowledgeable about is a very interesting, like, engineer-focused world and mindset that researchers oftentimes are only begrudgingly kind of participating in and working with, and oftentimes don't make computationally optimal decisions. I'll finalize this by saying that I witness crazy amounts of idling of GPU resources not from like the provider standpoint. Somebody's paying for it, right? So for them, they don't care how you use it, right? But from so many people whose resources are for GPUs are not being consumed in the optimal way because they don't have like effective job scheduling infrastructure or discipline even in how clusters get used or GPUs get used. And so when people talk about things being expensive, a lot of times it is possible to get 10x reductions in prices or more just by having discipline rather than solving a whole lot of like fancy math or any fundamental architectural.
Yeah, I think so. In my perspective, at least, like there are 2 different perspectives in this field. One is the infrastructure, right? That like how to, I don't know, to manage and how to interconnect between the different GPUs and and what do you actually need in order to do it and to run it. And in this perspective, I think, at least in my opinion, AWS, both AWS and Azure are much better than the others. Like, we tried at Wand, we tried to use Nevius, for example, and again, at least in my feeling, they're much cheaper, but they're infrastructure layer or like software stack was much weaker. It was like you need to spend a lot of time in order to, again, to manage and to understand how to put everything in place and to make it run exactly in the right time and to schedule the jobs and all these things. And in Azure, for example, or AWS, it was much simpler. Like, there are a lot of tools that you can use in order to do it. It's easier, and everything is just, click on this button, you can choose whatever you want, exactly the right amount of GPUs with the exact specification that you need. And the other perspective is the user perspective. And I must admit that, like, at this point, I thought that it will be a solved problem, that now we run one GPU or a GPU or 300 GPUs. It will be just automatic and very simple to scale it up. Now, it's much better, I think, than it was before. I don't know, in 2019 or 2018, right? If you want to do multi GPUs, right? Even not multi-node training. If you want to do multi GPUs, it was disaster, like TensorFlow, right? It was absolutely, you need to define so many details and like to define like the GPU that will be the main GPU, right? That will collect all the gradients and all the sub GPUs that we will do the partial computations, and it was disaster. And so it's much better, but it's still worse than I thought it will be at this point.
Yeah, I agree. And indeed, many players have millions of GPUs or more at this point. Inference is what's taking the vast majority of them, and probably not always in the most optimal way, where training is a really bursty workload of 1, maybe 200,000 GPUs. And oh, by the way, if you're that player doing that who's paying potentially hundreds of millions or billions for this bursty workload, you're also getting efficiency rates of flops, like due to the intercommunication, problems, well lower than 20%. Like, your efficiency rates are horrifyingly bad. And so, I'll use one complicated term. NVIDIA, at the very top end of their hardware that they actually sell to data centers, has something called NVL 72 right now, which is a setup where you have 72 GPUs that are all guaranteed to have fast, like one-to-one instant communication with each other. And so in principle, you have 100% efficiency of 72 GPUs. Well, you can do the amount of math to see how much that's equivalent to if you've got 20% efficiency, right? To say, okay, well, that's 72 times 5, right? Equivalent to, so we are really at the mercy of NVIDIA, right? All roads lead to NVIDIA. NVIDIA, at the end of the day, is the primary consultant with the biggest players for like major AI training, runs. And that part kind of, I always thought that there was, any way outside of it, right? But like I just mentioned to you, DeepSeek got massively delayed when they tried to avoid going there for training. And they also wrote a love letter in the form of the 2 pages telling NVIDIA what they wanted in Rubin, right? The next generation of GPUs coming out soon, in that paper.
Yeah, do we know why actually TPUs, no one actually used TPUs besides Google?
Yes. So I would encourage you, as well as all, maybe you already are, Ravid, but for all the viewers to subscribe to a magazine called Semi-Analysis, which does extremely reliable number crunching on this question. And basically the problem with TPUs is as follows. So in general, GPUs are not just graphics processing. You could also imagine the G stands for general purpose, like parallel or something. That's not a real acronym, but it's applicable to how GPUs are hard to code on, but compared to other parallel accelerators, it's a walk in the park. TPU programming is significantly more difficult. Things that just work on GPUs and suddenly don't. Things related to numerical precision stop making any sense compared to what you would expect. And while you can put developer time into learning all of this, let's say you do all of the optimization, in most cases you barely break even. Compared to just using B200, for example, because NVIDIA is so much faster at iterating and releasing, has so much more volume. So TPUs are almost exclusively, like in large quantities, used by their internal workloads, mostly for inference, where Google's stuff, it just freeing up GPUs to sell makes them worth it, right? Like, but no, they are not, they're not a proper replacement. And in general, with the exception of very fast inference, there haven't really been anything else, right? I mean, there's Cerebrus, Grok with a Q, TensorTorrent, dMatrix, and Samba who are doing these, giant, like almost not chiplet, but they call it language processing units, or bespoke designs, but they can't get these into large quantities to be hosted. Like outside of tech demos, they haven't really materialized as real competitors yet. So again, all roads lead to the GPU, and to specifically NVIDIA, because AMD's software for all of this is in the Stone Ages and continues to be. So
Yeah, so it looks that we still keep our GPUs, right?
yeah.
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 I think, yeah, it's a great question at the end. Like, what when you need to choose a cluster, right? GPU's cluster right now. You are a startup, let's say, at the beginning of the way that need to choose your cluster provider. What are the things that you are going to take into account, right? Is it the price? Is it like how easy is it? Like the reliability of the GPUs? There are a lot of things that you need to take into account.
Yeah, and I think, like all the other technologies that are emerging, nobody's got the right, all the answers. So I also see we are, getting maybe close to our self-imposed arbitrary limit of an hour here. But I see you have a paper here, titled Knowledge or Reasoning, a close look at how LLMs think across domains. And I'd love to hear what you have to say about this paper.
Yeah, so this is I found it as a great paper. Mostly the question that it asks is really important. So this paper tries to investigate a very fundamental question. What are the respective rules of knowledge and reasoning in LLMs and in the thinking processes, right? And how can we actually separate between the two over different domains? Okay, so the core innovation, or the core method that they actually use, is to decompose the evaluation, to decompose the evaluation framework, if you want. So they look on the intermediate steps or the reasoning steps, and they looked on two different metrics. The one is the information gain, what they call the information gain, or how much each reasoning step reduced the uncertainty for the final answer. Okay, and here they use perplexity. They use the perplexity calculations, okay, to track the confidence changes. And you just look on the average of the perplexity improvements across all the reasoning steps. Okay, so higher information gain means more efficient reasoning. And lower information gain means that you have redundancy in your informative steps. And the second metric is the knowledge index. And this is, and I think this is maybe the most interesting one. And it evaluates the factual correctness of knowledge that's used in each step. So the way that they did it is they used three-step process. So first, for each step, they extract the knowledge in this step. They extract the claims from this step. Okay, and then they query some external database, for example, medical database, for ground truth. Okay, so for example, if you have I don't know, if you have like does this for example, like the model says that you have this disease and we need to, this disease cause this thing. So the question is like, you can ask the question, like find the answer, like what this disease actually cause, right? Or like what are the reasons, or what are the factors that affect this disease. And now when you have the answer from an external source, you can compare the answer that your model in this step gives you and the actual true knowledge, or the actual true information, and you compare and you calculate if the model gives you the right answer. Okay, so this is like the if you have higher knowledge index, it means that you have more accurate domain knowledge, if you want. So you have these two metrics, and now you can calculate them over different tasks, over your reasoning process. So what they actually found, so they found a lot of things, but the main thing that they found is that they compared SFT and the RL, the supervised fine-tuning and RL, and they found that SFT increased the final accuracy, both in different domains, and so it improved the knowledge correctness. Okay, the knowledge that for the intermediate steps, so it become better and better, but at the same time it reduced the reasoning efficiency. Okay, so basically you have more knowledge, but it takes you more steps and they are less efficient. It's less efficient to extract this knowledge. So the model, if you want, the SFT in some sense helps models memorize the domain facts, but often introduce a very redundant reasoning process. Compared to the RL, that in the RL it enhances reasoning quality across the domains, and it improves the knowledge correctness. Okay, it improves the knowledge correctness, and it did it by pruning the incorrect information. So in some sense, the mechanism of RL, it works by eliminating reasoning paths that are containing incorrect knowledge rather than adding new facts. they have a lot of things that they did in the paper. It's very nice paper that you should read. But I think the core question here is very important at the end. Like, how can you distinguish between memorization or like acquiring new knowledge versus memorize and just like make it more efficient or inefficient, if you want. And there are a lot of different ways to distinguish between these two things. But I think this is a very clean and elegant way to do it.
This is fascinating. It really gets at the heart of stuff we talked about like earlier in this discussion. Did I correctly interpret then that SFT was deemed as superior to RLHF in this case? And if so, that's nice, because I think you've conjectured in the past that RLHF has issues. All right, so
yeah, so I think it looks that they are doing different things, you know. Like, it really depends what you want to do. If you want now to find the right path that already inside the model, then you probably want to use RL. But if you want to extract more information or like to improve the knowledge correctness, if you want, then you need to use SFT. And again, it's a trade-off, and how to find the right solution or the right balance, it's I think it's an open question. If we can find a method that actually use or make it better in both metrics, I think it can be very valuable.
very interesting. Yeah, you've given me a lot to think about here. I'm gonna have
Yeah, you
to
should
read
read it.
this.
Paper.
Yeah.
Okay. So yeah, I think we finished all the things that we wanted to talk about them today. Do you have anything to add?
No, we'll hopefully you have a lovely rest of your day or night, wherever you are, who's listening to us. Thanks.
Thank you, everyone, and see you next week.